Welcome everyone, and thank you so much for your time. So in today's science communication, we're diving into the amazing world of educational neuroscience and what it has to offer to educationalists. This topic spans a wide demographic. However, in today's session, our lens will zoom in on a crucial stage, which is adolescence. And it's a period I'm sure you all remember. It's marked by extensive physical alterations, but also important brain changes. So for our time today, we'll start by making sense of some important key terms. Then we'll explore why understanding the brain matters to educationalists and parents and the importance of the topic. We'll uncover how neuroscience can shed light on education with a focus on teens through examples and case studies. We'll also acknowledge limitations of educational neuroscience, discussing the challenges of applying these findings in real-life classroom. And we will have some exclusive guest speakers. And lastly, we will conclude this great episode on what neuroscience has to offer to educationalists. So, what is education neuroscience? It's a combination of psychology, neuroscience, and education aiming to improve teaching and learning, and offers us a complete picture of how we learn, because we know learning is complex. Now, we wanted to talk about neuroplasticity today because it's the brain's amazing ability to reorganize itself by forming new neural connections throughout life, helping us adapt and change. And this is very important because it contradicts old beliefs that our brains were fully developed by age 3. And now we know that our brains keep changing and adapting, which is a game changer for education and personal development. So neuroscience in adolescence got a lot of interest because new studies were challenging the previous notions that, for example, intelligence was stabilizing by the age of 10, and rather suggesting that cognitive abilities are subject to change. Further, research has also shown that adolescent brains develop unevenly, with certain regions maturing more slowly, and these could be influenced by hormones, but it contributes to the emergence of late developing skills such as responsible decision making and perspective taking. So these insights provide a really valuable understanding of the unique behaviours and social dynamics observed in teens to enable research to propose strategies to optimise and support the learning of adolescents. Now, why is this topic important? First, it shapes teaching methods to match how the brain learns, supports inclusive classrooms by understanding learning differences, and can really empower teachers with strategies to engage students and enhance their achievements, their success. So, for example, it's been used to support in areas of special education, addressing the needs of children suffering from developmental language disorder, dyslexia, attention deficit, and even social and emotional disorders. Second, neuroscience plays a crucial role in dispelling neuromyths. For instance, the learning styles theory, which suggested individuals could learn best by using their preferred style, such as visual, auditory, etc., has now been discredited by scientific evidence. So neuroscience can be really helpful and now instead promotes teaching methods that align with how brains naturally learn. Now, however, the critical question remaining is, are all strategies truly effective and broadly applicable in varied contexts? Should we allow teens to have longer sleep and initiating school hours later if neuroscience recommends it? Let's go and see some case studies and examples. So our first case study is from Queen's Anne School, who have been applying Brain Can Do, an innovative program based on educational neuroscience and psychology. Queen's Anne School, a boarding and day school for girls aged 11 to 18, has pioneered the use of a teacher's handbook that amalgamates the latest research in neuroscience and psychology and offers practical strategies for its classroom application with adolescents. This handbook has transformed teachers into facilitators equipped with knowledge of brain science and the tools to transform this knowledge into effective teaching practices. Now, beyond the classroom, Queen Anne School embodies a growth mindset culture, which is the belief that abilities and intelligence can be developed, or how we emphasize the power of mindset over innate abilities in determining student success. And they have found this culture has been instrumental in shaping students' attitude towards learning and have shown incredible results. Here in our second example, researchers have highlighted the intersection of neuroscience, adolescent cognitive development and education, particularly in relation to science and mathematics. So the authors wanted to study how the neural and cognitive changes occurring during adolescence can influence the development of science and mathematics skills. They draw particular attention to misconceptions that commonly arise in these disciplines during adolescence. And they explain that misconceptions can stem from misleading perceptual cues, experiences that seem to contradict scientific reality, or simplified ideas that were taught at an early age that are later refined and complicated. So we have a few of these misconceptions on the screen, and the authors suggest 2 key strategies to help teachers enable students to overcome misconceptions. First, allow students more wait time, so time to pause, so that they can engage their executive functions like inhibitory control before responding. Second, the author suggests to make students aware of potential misconceptions, explaining why certain appealing answers may be incorrect to foster metacognition, for example. Now, it's important to remain critical as these case studies and examples do not come without any limitations, and some of the critiques and challenges that education neuroscience has received can be found in each of them. So, for example, a first big challenge is applying brain science in the classroom and can be very difficult for educationalists. Not all institutions will be identical to Queen's Anne's boarding school. And recently we interviewed teachers from a mainstream school in Milton Keynes who revealed they had difficulties in integrating novel methodologies, particularly when dealing with teenagers as stage where they are going against norms or being resistant to authority. And these teachers reported having to tailor their lessons to cater to the wide spectrum of neurodiversity within a typical modern class of 32 students, which is a lot to manage. And when I presented to them the example of the misconceptions and advice, they simply said they wouldn't have the training or the time to implement this with their teens. Now, there are also problems with how to fund and reward this type of interdisciplinary work. And there's also some ethical issues as we do not know the long-term consequences of some of the studies. Finally, although neuromyths, some have been dispelled, certain misconceptions still remain. So, for example, the growth mindset, which we saw in Queen's Anne School, is often overemphasized, and it showed to be very positive at Queen's Anne, but critique have argued that it can potentially discount the effects of other important factors like socioeconomics, background, genetics, learning difficulties, or the quality of teaching and resources available, highlighting the danger of oversimplification. Now, despite these challenges, it is clear that many teachers are interested in using brain science in their classroom and making the most of the literature. However, they need more support in doing so. And the key point here is that there's no easy or quick solution to improving teaching with brain science. It will take time, teamwork, careful exploration, and this is where Centre of Educational Neuroscience, BNA, and Brain Can Do can help schools by offering the support. Now, there are many suggestions to help apply neuroscience results and enable educationists to use them. And an interesting paper written by Dr. Dormit, which is one of our key speakers who will appear shortly, is around the idea that educational and school psychologists, due to their understanding of both neuroscience and education, could play a crucial role in bridging these fields. And despite their role in educational neuroscience that may have been limited so far, leveraging their knowledge and skills and position could foster a stronger collaboration between education and neuroscience and help educationalists, ensuring accurate information reaches teachers and ultimately improving student outcomes. Our final section of the science communication are snippets from interviews we had the pleasure of conducting to gain additional insight. Our first guest is Dr. Ellie Domit, who joined King's College in 2015 after conducting extensive research in both neuroscience and pedagogy at Oxford University. And our second guest is Dr. Clemens Kircher, a researcher in neuroscience and education, and also a lecturer at King's College.
One of the problems that neuroeducation has had for many years since it started is that it hasn't really worked. Educators haven't communicated with neuroscientists, neuroscientists haven't communicated with educators. They haven't found a common ground. And so a lot of the promise that was expected to emerge from this exciting new discipline in the 60s hasn't really come to fruition. We're now utilising online learning in a way that we never had before. There are huge benefits to online learning, and there is a huge amount of expertise about it. So a lot of the work we're doing at the moment is looking at neurodiversity in online learning and also in higher education. But we haven't really done any research into those cohorts in higher education. So we don't know what's needed, and it is going to be very different to what's needed at school level. So I think one of the areas where it's really important to focus on now is to look at higher education for neurodivergent students in particular, and to make sure that we are focusing on online education as well, or more importantly, perhaps it's better to say the whole educational experience.
There are multiple levels or multiple layers to this. So certainly the thing that you mentioned, people with learning difficulties, that is something that we've only really started to fully appreciate in the last 10 to 15 years, maybe, with the finding that a lot of neuropsychiatric disorders, including things like ADHD, anxiety, etc., are likely to have a physical and genetic basis. Also, more generally, understanding how learning works, how long-term memories are formed. And I think that can feedback on learning strategies. One thing that I find particularly interesting is subconscious biases. The neuroscientific view here would be that we all have certain prejudices. A lot of this actually has an evolutionary origin. So basically, the way how our brains are wired and how we approach people who think differently from us is probably a function of evolution, and hence it's so difficult to overcome these biases and prejudices that we have. Potentially something that helps us to overcome that a little bit easier, or maybe also to just be a bit more tolerating of people who are not necessarily of our own opinion.
Thank you so much for joining this exploration into education neuroscience today. We've navigated its potentials with examples, but we've also seen challenges, emphasizing the need to bridge neuroscience results and classroom realities. From unraveling brain-based learning processes to debunking neuromyths, we've highlighted neuroscience's valuable contribution to enhancing teaching, especially for adolescents. Thank you for participating in today's exploration, and I hope this stimulates your interest to delve deeper into education neuroscience. Remember, your perspective as educators, parents, and stakeholders are invaluable in this dialogue. Together, we can shape a more enriching and effective educational environment for all our learners. Thank you very much.